Welcome to Amity E tutorial. This is Sheelam. We will discuss the topic basic transformations like translation, rotation, and scaling. The content we will discuss here is Introduction to Transformation, Translation, Rotation, Scaling, Reflection, 2D matrix representation. What is transformation? To transform something is to change. A geometric transformation is an operation that modifies its shape, size, position, orientation with respect to its current configuration operating on the vertices. The main transformations are translation, rotation, scaling, reflection. Transformations can be renamed. The original shape is labeled with the capital letters. See in the figure, it is denoted by capital letters A, B, C, D, and the transformed shape or image can be labeled with the same letters with a prime symbol attached on it. So what is translation? Translation is nothing just moving an object across the screen from one position to another position. The original object and the image have same shape, size, orientation, translation. In this figure, we have a triangle PQR which is translated 4 in the x direction and minus 3 unit in the y direction. So we can write it x plus 4 and y minus 3 and can be denoted by the symbol P dash Q dash R dash. Let's examine some translations related to coordinate geometry. The example shows how each vertex moves the same distance in the same direction. In this figure, a triangle ABC moving 6 units to the right direction, so it is denoted by A dash, B dash and C dash. So what is translation vector and what are the coordinates? It is denoted by A, B, C or A dash, B dash, C dash as it is filled in the chart. Let's take an example. Translate a triangle ABC with the coordinates A 1, 1, B 5, 2, C 3, 3. About the origin 3 units in x direction, 2 units in y direction. So we have delta x3, delta y2. We have the matrix Ax, Ay, Bx, By, Cx, Cy is equal to 1, 1, 5, 2, 3, 3. So we can write new coordinates Ax dash, Ay dash, Bx dash, By dash, Cx dash, Cy dash is equal to Ax, Ay, Bx, By, Cx, Cy plus delta x and delta y. So we have the matrix 4, 3, 8, 4, 6, 5. The linear coordinates of the translate triangle will be A dash 4, 3, B dash 8, 3 and C dash 6, 5. Now we will discuss about the rotation. A rotation is a transformation that turns a figure about its fixed point. It describes center of rotation, direction of rotation, degree of rotation, the original shape and its rotation having the same shape, size and orientation. Direction of rotation is depending upon how you take it, clockwise or anti-clockwise. If you're taking clockwise, it will be negative sign, or if you're taking anti-clockwise, it will be a positive sign, or vice versa. In this figure, we are rotating point P having coordinates x, y to a new position P dash x dash, y dash by an angle theta. The point P is making alpha degree to the horizontal. We are considering counterclockwise rotation as a positive and clockwise rotation as a negative. Mathematically, we can find out the coordinates of point P dash. It can be written as x dash is equal to r cos alpha plus theta and y dash can be written as a r sin alpha plus theta. We can open cos x plus y formula. It can be r cos alpha cos theta minus r sin alpha sin theta. And sin alpha plus theta can be opened up r sin alpha cos theta plus r cos alpha sin theta. Substituting these values, we can find out x dash is equal to x cos theta minus y sin theta, y dash is equal to x cos theta plus y sin theta. Rotation of angle q about the pivot point xr, yr. Now, what is scaling? Scaling can also be called Dilatations. Scaling is the transformation used to change or increase or decrease the size of an object. It has same shape, orientation but different size. It has a center of dilatations, a scale factor. A dilatation used to create an image larger, it is called enlargement. A dilatation used to create an image smaller, it is called reduction. Here, some assumptions involved in the scaling. Scaling is the transformation used to change, increase, decrease the size of an object. Scaling factors can be denoted by Sx along x direction, Sy along y direction. Scaling factor always as a positive. If the scaling factor is less than 1, the object is compressed. If it is more than 1, the object is stretched. The scale factor are equal, that is Sx is equal to Sy is equal to S, the object changes in the size, not in the shape. Thus the scaling is called uniform scaling. If the scale factors are different, Sx is not equal to Sy, the object change size only, not in shape. This is called non-uniform scaling. Here an example is taken in which a scaling factor is applied in different directions. Now matrix representation can be written as x dash y dash is equal to sx0, 0 is y, x and y. It can be symbolically represented by p dash is equal to s into p, where p is the original coordinates. This is again an example of scaling. Here a triangle ABC is scaled by 2 units in all the direction, and now it is denoted by A dash, B dash and C dash. The new coordinates will be -4, -4, B dash is equal to 2, -2, C dash is equal to 0, 4. So what is reflections? Reflection transformation produces a mirror image of an object. The reflection is described by the line of reflection. An object and its reflection have the same shape and size but opposite orientations. Before going to reflection rule, we know that 3 by 3 matrix can be written as 1 0 0 0 1 0 0 0 1. Now come to the reflection rule. If we reflected any image about the x-axis, it have x with the same value and y having the negative sign. Reflected any image about the y-axis, x having negative value and y having the same value. If we reflect anything about the xy plane, that is origin, then x and y both having the negative values. Thus this picture shows a translation, rotation, dilatation or reflection. Do you know? Yes, it is rotation. Another example is, does this picture shows a translation, rotation, dilatation or reflection? Do you know? Yes, it is scaling or dilatation. Which transformation is applied here? Yes, it is reflection. 2D matrix representation. 2D translation can be written as x dash y dash 1 is equal to 1 0 tx 0 1 ty 0 0 1 into xy 1. Here tx and ty are the translation value in the x and y direction. 2D rotation. X dash y dash 1 is equal to cos theta minus sin theta 0 sin theta cos theta 0 0 0 1 into xy 1. 2D scaling can be written as x dash y dash 1 is equal to sx 0 0 0 sy 0 0 0 1 into xy 1. Here x dash y dash 1 are the new coordinates, x, y and 1 are the original coordinates. Can you name examples in real life of each transformation? Translation, rotation, reflection and scaling? Today's topic, basic transformations like translation, rotation, scaling, reflection is completed. Thank you so much.